Galvin. Part 1. System calls. System calls are the programming interface to the service provided by OS. When a user program gives command to create process using the library APIs, the call will be sent to runtime environment. Application Programming Interface. An API is a set of functions that are available to an application programmer through library code to invoke actual system calls. As an API has functions, it might also have parameters to their particular functions. The parameters of these functions will be stored in registers, a stack, or a memory block. If the data is stored in stack, it can be pushed by the program and popped by OS. If data is stored in memory block, the reference of the data is stored in registers. Example of a library in Unix and Linux programs in C is libc. Example of Windows function create process API which invokes NT create process system call in Windows kernel. Three common APIs are Windows API, description Windows system, POSIX API, description POSIX based system, Linux, Unix, Mac OS. Java API description programs which run on JVM. Reasons for preferring APIs rather than actual system calls are portability, means can run on any system supporting the API. Simple, said to be simple because system calls are more complex than APIs. Similarity, system calls within kernel and functions in API are strongly correlated. Many of POSIX Windows APIs are similar to native system calls. RTA, Runtime Environment, is the full suite of software needed to execute applications, which includes compilers or interpreters, libraries, and loaders. RTA provides system call interface and serves as links to system calls by intercepting the function calls in API and by invoking the system calls. RTE maintains table of system calls with its associator number and returns status of system calls. Once the request has been made to the OS to execute a system call, it gets its implementation in the OS and after execution, it returns the status back to RTE. Types of system calls: process control, file management, device management, information maintenance, communication, and protection. Process control: create process and terminate process. Create process if both programs continue concurrently, we have created a new process to be multi-programmed. Terminate process: end or abort OS returns control to interpreter. In interactive system, it might alert user. Load and execute. A process executing might want to load and execute other programs. Control is returned to interpreter after its execution. Get and set process attributes. Ability to determine and reset attributes of a process, like process priority, max allowable execution time, and other. Allocate and free memory. Two or more processes share data. For data integrity, OS allows lock on shared data. Acquire lock. Get lock on the resource. Release lock. Release lock on the resource. Wait and signal event. Wait event. We might wait for a specific event to occur. Wait time. Having created a process, we may need to wait for them to finish their execution for a certain amount of time to pass. Signal event. The process should then signal when the event has occurred. File management. Create file or delete file. System call requires the name of a file and perhaps few file attributes to create and delete. After creation, we might need to open to use it and close it after usage. Read, write, reposition. We may want to read, write, and reposition after opening the file. Get file attributes and set file attributes. File attributes include file name, file type, protection codes, accounting information, and so on. Some operating systems provide many more calls, such as move and copy. Device management. Various resources controlled by OS can be thought of as devices. Some of the devices are physical devices like disk drives. Others can be thought of abstract or virtual devices like files. If resources available, process will allocate. If not, it has to wait until sufficient resources are available. Request or release device. A process may need several resources to execute. Main memory, disk drives, access to files, and so on. Request device. If multiple users for file system, we may require to request to ensure exclusive use of it. Release device. After we finished with the device, we can release it. Two common models of inter-process communication. Message passing model, shared memory model. Message passing model. It is used for small amounts of data and no conflicts are there to avoid in this model. Shared memory model. Communication speed in this model is almost equal to the memory transfer speed. Message passing model. Messages can be exchanged between the processes either directly or indirectly through a common mailbox. Before communication can take place, a connection must be opened. The name of the process that is being communicated or that is communicating has to be known, either using get host ID or get process ID system calls. This will be translated to an identifier for the reference of the OS to the process. If two processes communicating in message passing model, it will be client process and server process. The server process are almost special purpose daemon which waits for connection. If there is no connection call, it won't awake. If there is, it gets awake. Shared memory model. Processes use shared memory create and shared memory attach system calls to create and gain access to the regions of memory owned by other process. Normally, the OS tries to prevent one process from accessing another process's memory. Shared memory requires that two or more processes agree to remove this restriction. Can exchange information by reading and writing into the shared areas. The form of data is determined by the process and not under OS control. Processes are also responsible for ensuring they are not writing into the same location simultaneously. Message passing model is useful for exchanging smaller amounts of data because no conflicts needed to be avoided. Also, easier to implement than shared memory for inter-process communication. Shared memory allows maximum speed and convenience for communication since it can be done at memory transfer speeds when it takes place within a computer. Problem exists for shared memory, however, in the areas of protection and synchronization between process sharing memory. Create and delete communication connection. Identifiers are passed to general purpose open and close calls depending on system model of communication. The recipient process must give permission for communication to take place within an accept connection call. Attach or detach remote devices. System calls to gain access and release access to regions of memory owned by Transfer status information. Status information in between communication is required to act accordingly. Send receive message commands are used for sending and receiving messages during communication. Protection provides a mechanism for controlling access to the resources provided by our computer system. The allow user and deny user system calls specify whether a particular user can or cannot access a particular resource. Get file permission and set file permissions. System calls providing protection include set permission and get permission, which manipulate the permission settings of resources such as files and disks. Information maintenance. Many system calls exist simply for the purpose of transferring information between the user program and the operating system, like version number, OS, amount of free memory or disk space, time, date, and other. Another set of system calls helpful in debugging a program are dump memory, strace, or strace. Get process file or device attributes, set process file or device attributes. Generally, these calls are also used to get and set the process information. Even microprocessors provide a CPU mode known as single step, in which a trap is executed by CPU after every instruction. The trap is usually caught by a debugger. Time profile by OS requires either a tracing facility or regular timer interrupts. At every occurrence of the timer interrupt, the value of the program counter is recorded. In addition, OS keeps information about all its processes and system calls are used to access this information. This particular PDF link is attached in the description, and also a written notes for this is also available. These are the contents in the notes which are made short from the textbook for quick revision.